Hello everyone. In this session, we will be looking at how we can detect face and parts of faces using only OpenCV and Python. We will be using HAL classifiers, returned XML file, and just some of the useful OpenCV methods to detect faces and its features. Now you might ask, what is HAL classifier? HAL classifier is a classifier trained to detect faces and features of faces. It is present on tons of positive and negative image of data and is able to accurately detect faces and its features. What we are going to do is load the HAR classifier's pretend XML file using OpenCV's cascade classifier method, in which we just pass the path of the XML file and the function will load the cascade into memory for us, so we don't have to do anything. Let's look at the implementation now. Prerequisites for this session is OpenCV library only. You can install it on your local device by typing pip install opencv-python on your command prompt. I will be using a Python notebook on Google Colab, and since it has OpenCV installed already, I won't have the need to do this. Then we import OpenCV in our Python notebook. I have to import cv2_imshow because Colab does not support OpenCV's imshow method, so this is a great workaround for it. Let's read the original image and show it using OpenCV's imread and imshow method. This is how our example picture looks like. In this session, I am using cascade files for frontal face and eyes, but there are cascade files for other features of faces too. That's the great thing about OpenCV. We can just use these features in our program with just some lines of code. To load our cascade files, we use the cv2.cascade classifier method and we pass the path to the pretend XML file. We don't have to install the XML file. If you put cv2.data.har cascades, it will get the files for you. Our program will detect faces using detect multiscale function, which will take three arguments: input image, scale factor, and min neighbors. Scale factor specifies how much the image size is reduced with each scale, and min neighbor specifies how many neighbors each candidate rectangle should have. We have to keep in mind that detect multiscale only accepts grayscale images. So we have to grayscale our image first using convert color method. You can play with the arguments and see what suits you best. Detect multiscale will pass a list of x coordinate, y coordinate, width and height to the variable. We will loop through all the values in the faces variable and draw a bounding box around the face using those coordinates with cv2.rectangle function. Now we have drawn a bounding box around the face, but we have yet to detect eyes in our example. So what we are going to do is get a region of interest around the face and detect eyes again using detect multiscale function. Point of making a region of interest is just so we can authorize the pair of image to certain person if needed. And another reason would be it will work faster as it won't have to process the whole image, but we'll have to process just the face part in the image. And we can loop through the detected eyes and draw a bounding box around them as well. Now let's see how the output looks like. You can see how perfectly our bounding box has fit to the face and eyes in our example. And just like this, it is very easy to detect other features of our face as well with just some lines of code. And it is all possible using OpenCV and Python only. Here concludes our session of face detection using OpenCV. Thank you.